the answers to the problems in chapter 34. And since I had done a lot of work on the quiz and trying to explain it really clear, and this has already been gone over in class, I will be a little bit faster in this one. Question 1, remember that's the diagram, and for small angles, sine theta equal to tan theta equal to theta. If you call that as x, then sine theta is x by L, where L is the distance between the slits and the screen. And so, d sine theta is equal to m lambda. So you can rearrange and put that as x1 is lambda. It should just be lambda ml. Anyway, by d, and because it says a consecutive one, the next one should be m plus 1. And the difference between the two, delta x, is lambda L by d. In fact, that is the expression for bandwidth, or the width of one fringe. Now rearrange that and make lambda the subject. That's the distance between the screens. And then you have 8.5 centimeter into meter, and you calculate it as 6.8 times 10 to the negative 7 meter. If that's the wavelength, then the frequency is just c by lambda. Which is 4.4 times 10 to the 14 hertz. In the second question, the wavelength of light is given. It says the fourth order fringe is 38 millimeter from the central fringe. So now again, that's x. You have to find d. As before, for small angles, sine theta, approximately equal to tan theta. And we've got this before, so make d the subject. So and d is 1.4 times 10 to the negative 4 meter. Now, one of the reasons why m is taken as 3 here is, now this is a special problem because it doesn't say whether it's a bright fringe or whether it's a dark fringe, right? M is equal to 0 is for the central one, and if it's, so that's why this is a special case. In all other problems, just go by whatever m is equal to the order. In the third question, gives you the wavelength and tells you that the second order maximum. For second order maximum, m is equal to 2, because when m is 0 is the central maximum. Okay. Once again, the same formulas. You're looking for d sine theta now. You got m lambda, and for a minimum, because you're asked to find what wavelength of visible light would have a minimum at the same location, which means d sine theta should be the same. But the condition for minimum is m plus half lambda. And then it's trial and error. If m is 1, I think there was a break in recording, but anyways, I forgot to switch on the record. Here you see that the constants cancel out in this question, and you have x1 by x2 is 1.154. So you get x2 10.4 millimeter. Now in the fifth one, introducing this thin piece of plastic is going to change the path difference. And that's introduced in only one slit, so it's going to, instead of being a maximum, the center point became a minimum. That means it introduced a path difference of lambda by 2. A crest became a trough. And then you have the number of wavelengths in the plastic minus the number of wavelengths in, number of waves actually, in air is T by wavelength. See, thickness divided by the wavelength gives you the number of waves. So, to get the difference now, and this right here is an important one too, which has been well explained. So rearrange that, find T. In the sixth question, white light is reflected and you've got to find the minimum thickness of the coating, T. Here again, remember that you have to look for the additional path difference. And there is an additional path difference of lambda by 2 in both of these cases, so they cancel out and the path difference comes out to be 2, it should be 2t times n. I'm going to change that, or 2nt. Now for constructive interference, you know that it should be equal to m lambda, and m should be 1. Because it's minimum thickness, so you go for the minimum value of m, which is 1. Okay, now I've corrected it. It should be 2nt. Even here was supposed to be corrected anyway. It's 2nt. And you calculate t. Okay, now. Right, in the seventh question, oil and water. So first case, there is an additional path difference because it's going from air to oil. Second case, it is trying to go from oil into water. Oh, what is this? Seventh question. Oh, here the refractive index of oil is bigger. So in the first case, it's going from a bigger one to a lower one. Second case, in the first case, it's going from air into 1.5. 1 to 1.5. So there is an additional path difference of lambda by 2. But in the second case, it's going from a bigger 1.5 to a smaller 1.33. So there is no additional path difference. And therefore, when you take the difference between the two, there's only one that underwent that. So there's no cancellation. You have to take 2nt minus lambda by 2. And it's asking for the strongest. So you go for constructive interference, or it says enhanced reflection, and now it's just a matter of calculation. Minimum thickness, so you go for the minimum value of m. And they're giving you two wavelengths here. So one is for red, the other is for violet. Excuse me. And you calculate for one and then you calculate for the other with the same formula, and look at if the numbers agree, because they have to be enhanced. And so you see that 325 is common, therefore the minimum thickness is equal to 325 nanometer. Brings us to the last one. Now you have two flat glass surfaces with air in between. First one is glass to air. Okay, the reflection is when it tries to go from higher to lower. Second one is when it tries to go from lower to higher. So it's in the second one that there is an additional path difference. So now you're going to say 2nt plus lambda by 2. You see, because already the second ray has a path difference of 2 times nt, and in addition to that it jumps by lambda by 2. So that's why it's 2nt plus lambda by 2. Condition for brightness, because it says when will it appear to be bright. Rearrange and find the thickness. See, each case is different. Remember that in this particular case, it's the second ray that has a jump of lambda by 2. And it already has an additional path of 2nt. So when you take the total path difference, it is 2nt plus lambda by 2. In all other cases, it was the first one that had an additional path of lambda by 2. Okay. So in that case, you take 2nt minus lambda by 2. In the third case, if both of them have an additional path of lambda by 2, then it cancels out and you only take the path difference as 2nt. I hope that's very clear. Now this problem has to be done assuming that it is dark. So instead of m lambda here, we are using 2m plus 1 lambda by 2 and do the problem the same way again. In which case it's 225 nanometer. Thank you.